Expression set viewer make it very easy to select one or more features and to do some analysis based on the feature you selected. So as an example, on the left side, you see the feature space, a volcano plot. You can select the one feature by clicking on the point here. So what you can see is the intensity of the protein, and it has a very big dynamic range. It ranges from 10 to the power of 5 to 10 to the power of 10. You can easily correlate this protein intensity with some other variables. As an example of quantitative variable, we select the doubling time of cell. Here, the scatter plot shows the x-axis is the protein intensity, y-axis is doubling time. We can check if there is a significant correlation between the two variables, and actually no, the p-value is not very low here. We can also compare the protein intensity with categorical variable, as example, TP53 status. On the left side, you see the protein intensity in cell lines carries mutant version of TP53, and all cell lines express wild-type TP53, and the protein intensity is on the right side. The significant test using parametric or non-parametric both tell a rather high p-value, so there's no difference between the two groups. Another important analysis can be done is the overall representation analysis. To use this function, you have to select the multiple proteins. As an example, we are selecting the proteins on the top right corner, which proteins are high expressed in the renal compared to melanoma. And here is the table returned by the Fisher's exact test. We can click on one of the terms to see which of the proteins we selected present in this cytoskeleton-dependent intracellular transport term. You can click on it, and the overlap gene is shown as the blue bar here. We can sort the table based on the p-value as well. Another analysis can be done is to connect to the string database, perform enrichment analysis, and network analysis. What we need to give is the taxonomy ID, here is human, and it returns to the table of enrichment analysis from string database. And if you can click on it, you can see the network here. The orange one are proteins present in this term you are selecting, and the blue one are the proteins not in this term. You can see which term is most significantly enriched. The last analysis can be done is the FGSEA. You don't need to select a subset of features, but you need to give a ranking statistic. As an example, we give mean difference between the renal and the melanoma using it as a ranking statistic. That is the figure you are seeing on top. And on the bottom, you see the table returned by FGSEA. And you can see the leading edge score by zoom in and check this red color. You don't have to select all the feature. You can also select based on the heat map. For example, you can see which gene sets are enriched in these genes. You can see here is very significant in mitochondrial translation, and what's here. And by doing this, you can check every corner of the heat map. I hope you can find this is helpful for your data analysis. Thanks for watching.